Alright, so welcome to our lesson today on special right triangles, and we're going to be looking at the 45, 45, 90 right triangle. So today's objective is we will be able to find the length of the sides of a 45, 45, 90 triangle by using the special right triangle shortcut instead of using the Pythagorean theorem. So there's a few ways that we can identify a 45, 45, 90 triangle. The first way here on the left, it's a right triangle and it's marked with the legs congruent, which is indicating that it's isosceles. Any isosceles right triangle is going to be a 45, 45, 90, meaning that it has angle measures of 45 degrees in the base angles and then a 90 degree in the vertex. The second way that you'll see a diagram for a 45, 45, 90 triangle is marked in the middle. This doesn't mark anything about the side lengths, but it is telling you it's an isosceles triangle because it has those two base angles marked congruent, and then the right angle would be our vertex angle again. And then the third way would be having an isosceles triangle marked with the two congruent legs, and then the 45 degree angle marked on the inside of one of those base angles. So three different ways that you could see a 45, 45, 90 marked. You need to be familiar with those so that you can identify them, because again, today we're looking for shortcuts to save us some time and to make us efficient in our math skills. So let's look at the old way, so to speak, of the Pythagorean theorem. We'll need to do this a few times so that we can start to identify and recognize that shortcut, or in other words, to identify a pattern. So what I want you to do is there are three right triangles on here, and they are isosceles, which means they are 45, 45, 90 triangles. I want you to go ahead and press pause. Use the Pythagorean theorem to solve these triangles and finding that hypotenuse side length. Make sure that you're using a radical and simplifying it so that you'll find that pattern. All right, hit pause and try it out. All right, so you've done the work. Welcome back. Here's the Pythagorean theorem work for each of these triangles. Remember, today we're not focusing on that work. We're focusing for the patterns. But in all three of these, I have gone out and written the Pythagorean theorem down, plugged in the A and B values, simplified it to find what c squared was, took the square root, and then simplified or reduced that radical. And that's the value we want to focus on today. So in the first example on the left, we have side lengths of 3. And his hypotenuse ended up being 3 square root 2. So the measures of all three sides were 3, 3, 3 square root 2. Let's look at the example in the middle then. I have two side lengths of 4, and the hypotenuse length was 4 square root 2. So the side lengths on this triangle were 4, 4, 4 square root 2. And then my third example on the right, that triangle had side lengths of 5 for those legs that are congruent, and a hypotenuse of 5 square root 2, making the three side lengths on this triangle 5, 5, 5 square root 2. Are you starting to pick up on a pattern here? Notice how it's always the two side lengths, and then our hypotenuse is the side length with a root 2 afterwards. So let's try a few examples using this shortcut. Here are two triangles. We want to find the missing hypotenuse. We're going to focus on the example on the left first. So here we have two side lengths of 11. So his hypotenuse is going to be 11 square root 2, because that gives me side lengths of 11, 11, 11 square root 2. What about this other triangle? It only gives me one side length. We want to start off with identifying and labeling that other leg that is congruent. So that side length would be 9 on the bottom. So the three sides of this triangle, including the hypotenuse, would be 9, 9, 9 square root 2. But what about problems that don't quite seem to follow it, but actually are following the shortcut? So this example on the left, I have 7 square root 2 on the hypotenuse, which means I need to find the length of the legs. Remember, our shortcut had the length of the leg with the square root of 2 after it, which means if I have a hypotenuse of 7 square root 2, the length of each leg is simply 7, because that's going to give me 7, 7, and 7 square root 2 for my side lengths. Okay? So whether or not you're given the side lengths or the hypotenuse, it's still following that pattern. Now, a small exception would be a problem like the one on the right, where my side length has a radical in it. In this case, 13 square root 5. Okay? But it does still follow the pattern. Remember, it's the side length times the square root of 2. So my side length is 13 square root 5, and then I'm going to times it by the square root of 2 for my hypotenuse. We can take these two radical values, the square root of 5 times the square root of 2, and use our properties to combine them, which means we're just going to multiply the insides. So the actual length of this hypotenuse would be 13 square root 10. It's still following the pattern of multiplying that side length by the square root of 2. It just looks different, so we don't notice that pattern is all. Okay? All right, so we've done 4 examples together. I have 3 examples here for you to try. Okay? So hit pause for a quick moment and go ahead and find all the missing side lengths of these 3 triangles. All right, welcome back. So you have found the missing side lengths of our triangles. Let's check our answers. So that first triangle, we need to fill in the missing side length of 14 because they are congruent. And we know that the hypotenuse is going to be the side length with the square root of 2, making it 14 square root 2. Our middle triangle gives us the hypotenuse length of 8 square root 2. So we need to find those legs, those congruent leg measures. If the hypotenuse is 8 square root 2, we're going to just divide or remove that square root of 2, giving us lengths of 8 for each of those congruent legs. And the example on the right, the length of 5 square root 3 for one of my legs. Start off with the easy part, the congruent side. So that's going to be 5 square root 3. Now, to find your hypotenuse, it still follows the pattern. Your leg length, 5 square root 3, multiplied by the square root of 2. The only thing we have to do here is one step of combining those radicals to simplify. So we're going to multiply the insides and find that the length of our hypotenuse ends up being 5 square root 6. Okay, so those are the most common types of 45, 45, 90 triangle problems you're going to see, okay? Whether it's in this class or whether it's next year in Algebra 2. But there are other types, and we'll call these the tricky problems, okay? And what I mean by tricky problems is, notice on my example, the hypotenuse does not have a square root of 2 in its length, which is throwing us off on our pattern, of side length, side length, side length, square root 2. So what are we going to do? The first thing we're going to do is label those congruent sides X. We're labeling both of them X because we know that an isosceles triangle has congruent legs on those sides, so they're going to be the same value. And then we're going to plug that into the Pythagorean theorem. Remember, we're not focusing on our work for the Pythagorean theorem today. We are focusing on our shortcuts and patterns. So here's the Pythagorean theorem. All the work's worked out. I put the X's in for my A and B, and I'm using 10 for the C. I square them and then combine my like terms on the left. So 2x squared equals 100. In solving for x, we're going to divide by 2, and then we need to take the square root. So x equals the square root of 50, and the last part of this would be reducing or simplifying that square root of 50. So that can break up into the square root of 25 and the square root of 2. And then the square root of 25 is 5. So we find that our side lengths are actually 5 square root 2, and we'll go ahead and put those in our diagram. But do we really have a pattern yet? Let's look at 2 other examples and see if you guys can find a pattern here. So here we have two examples. Take a moment, see if you can identify a pattern across these three triangles. Okay? Notice they all have whole number values for my hypotenuse. All right, so hopefully you found a pattern at this point. Let's see about applying it and making it common across our class. So here's an example, and we're going to say that this is indeed a 45, 45, 90 triangle. His hypotenuse is 6. The first thing we're going to do to go from a hypotenuse of a whole number is we're going to divide by 2. So 6 divided by 2 is 3. We're going to put that on both of our sides, and then we're just going to put a square root of 2 at the end of that. So 3 square root 2. Okay, let's do a few examples like this. Find the missing side lengths of our 45, 45, 90 triangle by using our shortcuts. The example on the left, we have 12. This is a whole number. It does not have that square root of 2 that we like. So the first step is divide by 2. So 12 divided by 2 is 6. So we're going to put those on each of our sides, and then we're going to put a square root of 2 at the end of that. So each side length is 6 square root 2 when the hypotenuse is 12. Let's do another one. This one has an example length of 30 for the hypotenuse. First step, divide by 2. 30 divided by 2 is 15, and then simply put a square root of 2 at the end. So 15 square root 2 is the length of each one of those congruent legs of my isosceles triangle there. Okay, now we have a few problems for you to try. The steps are right there written out for you, and there are two examples. One has the length of 18 for the hypotenuse, and the other is 40. Press pause, follow those two steps, and find the side lengths of my triangles. All right, so let's check your answers. When you divide by 2 and then put the square root of 2 at the end, these are the side lengths you get for both of those triangles. 9 square root 2 with a hypotenuse of 18, and then 20 square root 2 with a hypotenuse of 40. If you didn't get those answers, go back, check again. Check each step and see about making that correlation of where those numbers came from, but also where did you go wrong so you can identify that oops of yours and avoid it in the future. So a few things to remember. If we're going forwards, or the most common way, right? The hypotenuse equals the legs times square root 2. So here are two examples. If I am given my leg lengths, okay, those congruent sides, all I need to do is take that length and put a square root of 2. So that would make it a 9 square root of 2. Or if I'm given the hypotenuse and the hypotenuse has that square root of 2 in it, all I'm going to do is drop that square root of 2 off and get 13 for each of my side lengths. So 13, 13, 13 square root 2. Again, this is the most common shortcut way we are going to be looking at 45, 45, 90 triangles. Okay? But we will occasionally have when the hypotenuse is a whole number, so the side on the right of this screen. When that happens, that means we don't have the square root of 2 present in our hypotenuse. What we're going to do is divide by 2 and then put the square root of 2 at the end. So our example here being a hypotenuse of 24. It does not have that square root of 2 present that we're used to. So divide 24 by 2. We get 12 for each of those. And then we're going to put a square root of 2. So 12 square root 2 would be the length of each of those sides. So that's it for this lesson and learning about 45, 45, 90 special right triangles.